Welcome to the Podkey summary of Collaborate on Structured 3D Models in visionOS from WWDC 2026. Today's thread is spatial collaboration and how a design review on Vision Pro starts to feel less like passing files around and more like standing around the same workbench. The big ideas are shared 3D models over SharePlay, cleaner ways to structure and manipulate complex assemblies, and a really tactile clipping system that lets people peel back geometry instead of just toggling it on and off. And under all of that, there's a lot of practical engineering, coordinate transforms, collision setup, and some smart data-driven choices that make these experiences feel natural instead of fiddly. One of the standout ideas here is real-time spatial collaboration with Apple Vision Pro. Multiple people can look at the same high-fidelity 3D model at once, manipulate it together through SharePlay, and do it even if they're not in the same room. That changes the tone of a review completely, because it stops being one person screen sharing while everybody else squints politely. The experience is built around three things: real-time sync, rich manipulation of multi-dimensional data, and lighting that responds to the environment so the model feels grounded where you're viewing it. Put together, that's what makes it feel less like a demo and more like actual collaborative work. A lot of spatial interaction starts way before the interaction layer, with how the 3D asset is structured. If you preserve a deep-named hierarchy, code can address specific parts, isolate them, animate them, or highlight them without a fight. If everything gets flattened at the root, even simple tasks become annoying, because the engine can't reason about sub-assemblies anymore. That same organization also unlocks more advanced behavior. Things like auto-expansion and clipping logic become tractable when each node is independently addressable, instead of the whole model acting like one giant anonymous blob. There's also a neat reality kit detail around the manipulation component. If you place that component lower in the entity tree, each child becomes independently grabbable. Move it back to the root, and you restore whole assembly manipulation without changing the geometry itself. So the interaction model can shift just by changing component placement, which is a pretty elegant lever to have. And if you set release behavior to stay, parts remain where users leave them after release, which gives the interaction a more predictable physical feel. The clipping model is one of the more interesting pieces here. In visionOS 27, the clipping component can be edited through 6 interactive plane entities, one for each face of the bounds. So instead of clipping being a hard on-off switch, a user can pull a plane inward and reveal the interior geometry continuously. That turns clipping into exploration. You're not just hiding half the object, you're kind of feeling your way through it. The whole thing is governed by a 3-state machine: .off, .on, and editing. That controls whether the planes are hidden, whether clipping is active, and whether those handles are currently interactive, which makes mode switching much cleaner. What keeps that system from becoming a mess is that it's split across 3 custom components. Clipping bounds cache stores the persisted bounds, clipping component handles rendering time clipping, and clipping transform sync manages the UI-driven plane movement. That separation means each part has a clear job, and transitions between .off, .on, and editing stay manageable. It's basically a modular, state-driven design that feels a lot like classic MVC thinking, just adapted to spatial computing. There's also some coordinate frame gymnastics under the hood, and this is the kind of thing users never notice when it's working well. A drag gesture arrives in the clipping plane frame, gets transformed into world coordinates, then into model coordinates, projected onto the plane normal, and finally converted back into the plane frame so the visual handle moves correctly. That sounds like a lot, because it is. But the point is simple. The gesture should feel natural, no matter how deeply nested the object is. By isolating the math frame by frame, the system stays easier to reason about and responsive in more complex hierarchies. Another clever bit is auto-expansion. To decide which axis an assembly should fan out along, the sample computes the variance of subassembly positions and weights it by each part's volume. Then it picks the axis with the highest weighted variance. What's nice about that is it turns a design choice that could feel arbitrary into something data-driven. Bigger parts with more spatial spread have more influence, so the resulting expansion tends to read as more natural to the eye. One very practical detail: collision components are essential. In RealityKit, if an entity doesn't have a collision component, touches and gestures won't register through the event system. So manipulation can fail, clipping interactions can fail, and the app just feels mysteriously unresponsive. This apparently trips people up a lot when converting CAD assets, because collisions are easy to omit, and the failure mode is mostly silence, which is never the most generous debugging experience. On the collaboration side, SharePlay integration is what ties the review workflow together. The visionOS guidance is to expose a shared session ID and synchronized state so every participant sees the same model transformations. That means everyone is literally looking at the same change as it happens, not interpreting a laggy sequence of screenshots and annotations afterward. And in 3D, even gestures like pointing become useful communication. A hand gesture can act like an annotation in space, which is a lot more immediate than drawing arrows on a flat image. The future-facing piece here is spatial preview. Developers can stream a live Vision Pro scene to a Mac, which opens the door to remote debugging or mixed reality control of assemblies. It also hints at broader cross-device workflows, like overlaying virtual models onto physical rigs, such as a race car simulator cockpit. That's the bigger pattern underneath all of this. Spatial apps aren't just isolated headset experiences. They're starting to plug into a wider toolchain and a wider ecosystem. So the headline here isn't just that 3D models look good in space. It's that the collaboration, interaction, and software structure are getting mature enough to make spatial review actually useful. And when the math, hierarchy, collisions, and shared state all line up, people can focus on the model instead of wrestling the interface, which is really the whole dream. This episode was generated by Podkey. Create your own at podkey.fm.